We're on page 491. We're going to talk about rational functions. Rational functions are functions that have variables in the numerator and the denominator. Now, what's the big rule in mathematics about fractions?
Well, you can't divide by zero.
Can't divide by zero. Q of x cannot equal 0. So, if we have, for example, negative 2x over x squared plus 1. The very first thing you'll want to do is you'll want to decide which values you need to restrict. So you look at that function and tell me what values of x will cause the denominator to be 0. What's the first number that comes to your brain that you want to try in that spot? Do you think of -1?
Yeah.
Okay. But actually, if you use -1 for x, does that equal 0? No, because when you square -1, you get 1, and 1 plus 1 is 2. What happens if you use 0 for x? You get 1. So is there any way for this to equal 0, x squared plus 1 to equal 0, x squared would have to equal -1. Is there any way that can happen? No, because if I continue solving that, what I run into is imaginary numbers. So it's not, so this doesn't have any restrictions. So the domain is all real numbers. It could be written from -infinity to +infinity. Okay? Either way. You'll see it both ways. Now let's graph it and let's look at it. -2x divided by x squared plus 1. Look at that graph. Looks like a snake running across the screen. But I want you to look at it and I want you to tell me if you see any holes or gaps or breaks. Remember last week we were looking at those that had those branches and there were some asymptotes involved? Does this one have any holes or breaks in it? No. It is continuous. That goes hand in hand with being able to use any x value that you want in your domain. The next one we're going to look at is 1 over x squared minus 4. What value or values of x need to be restricted here? 2. Anything else? Let's see. You start by saying, okay, what if that equals 0? Well, if that equals 0, x squared would have to equal 4. And you're saying that if I square 2, I get 4. You're correct. Is there another number that would cause it? If I square -2, I get 4. So the domain is all real numbers except 2 and -2. Okay? It's everything from -infinity to -2, in union with the section from -2 to 2, in union with the section from 2 to infinity.
Cool.
Yeah, that's how you're going to enter it in college algebra next year. I'm just kind of giving you a heads up. This is what I'll be looking for in this class. Now, let's graph it.
I mean, that down there makes sense. It's just that
it's a lot to write. And if you were including the number 2 or -2, you would put a bracket instead of a parenthesis. So 1 divided, let's put in the graphing calculator, 1 divided by x squared minus 4.
graphs do not look like that. It's doing kind of like, so we're doing 1 divided by, my last one.
You're not putting it for 9.
Oh, that's it.
Okay.
Oh my gosh.
they occur? At 2 and negative 2. So it's discontinuous because of the two breaks. And the point of discontinuity is 2 and negative 2.
So that's the point that it discontinues.
Point of discontinuity. Okay? Let's look at the 2 and negative 2. What if we have this one? X plus 2 times x minus 1 over x plus 1. Now it's the denominator that I'm worried about, right? So what would make that equal 0? Okay. So the domain is all real numbers except negative 1. So it's anything from negative infinity to negative 1 in union with negative 1 to infinity. Let's graph it. Let's look at the graph. Open parentheses, x plus 2. Open parentheses, x minus 1. Divided by x plus 1. What happens? So it's discontinuous. What is the point of discontinuity? Okay. Does that kind of make sense to you? Okay. So if I have 1 over x squared plus 2x plus 1, what are we going to do to find the points of discontinuity? And then we're going to factor.
Here we go.
Always factoring.
I don't like
Always.
factoring. So
X and x.
and we just do one and one.
So x plus 1 could be 0. So x could be negative 1. X could be negative 1. Point discontinuity. X equals negative 1.
So this kind of what
What about this one? Find the points of discontinuity. Is it? Let's see. Let's set it equal to 0 and see what happens.
You disregard the continuity.
No, it's not.
Can this work? Can this happen? There are none. There are no points of discontinuity.
So you just disregard the top part of it?
For this part of the lesson, when it's asking you for points of discontinuity, yes, you're only focused on the
Okay.
denominator.
I was wondering where that was going to.
Yeah.
So on like the one where it's 9, do we have to just put 9 or do
You
we
just put 9.
Okay.
You just
So
put
how
9.
do you know when to use the factoring?
Well, had this had another x in it, I would have had to have factored it.
Oh, okay.
Okay. So far, so good?
Okay.
Okay. Now, since you brought up the top, there is a piece that goes with that. So let's look at the next example. It says x plus 1 over x minus 2 times x minus 3. And your first job is to find the points of discontinuity. And what are they? You can probably tell just by looking. 2 and 3. Now, if they also cause the numerator to equal 0, then they are called wholes. If they do not cause the numerator to equal 0, they are vertical asymptotes. So yes, 2 and 3, first of all, they are points of discontinuity. And then you have to decide whether they fit into this category or this category. 2 is a vertical asymptote when x is 2. When x is 3 is also a vertical asymptote.
But if it were like -1, then it would be a whole.
We got that? Can we do that? Okay, let's look at another example. X minus 2 times x minus 1 over x minus 2. So first find the points of discontinuity. Just the denominator. We just start with the denominator, where x equals 2. Now, is that a whole or is it a vertical asymptote? Does it cause the numerator to also be 0? Yes. So it is a whole. Okay. Now, this is your function. Can you simplify your function?
Yes.
For instance, if you had y equals 12 over 2, it would be like having 2 times 6 over 2, and you cancel the 2's. So these will divide away. So your function really is going to look like this. But there's going to be a whole at 2. So let's look at it on the graph. Let's see what that looks like. Let's see if it holds true to what it's supposed to do. If I can find a calculator that works. I guess they're up here because they don't work. Let's clear that out.
So you don't necessarily solve it?
Not today. Not at this point. Okay. So it's linear. It's what it appears because it looks like x minus 1. Let's go to the table and see what happens. Error.
Oh my gosh.
Why does it tell you there's an error?
Because there's
It's
a
supposed to go there
hole.
too.
But it doesn't because there's a hole. Because if it were 2, it'd make the denominator 0. We can't have that. Now, it gets us, here's your domain gets as close as possible. Negative infinity to 2 in union with 2 to infinity. So, I mean, on the graph is not sophisticated enough to show us the whole. But we would draw one if we were graphing it. We would just draw a circle and have the line run in that direction. Okay, let's look at another one. X minus 3 times x plus 4 over x minus 3 times x minus 3 times x plus 4.
All that top can cancel out.
3 and negative 4 are your points of discontinuity. Is 3 a whole or a vertical asymptote?
So if it just makes one of those,
Okay.
it doesn't have to make both of them equal 0. If it just makes one of them.
Right, because it's a multiplication problem. Because 0 times whatever.
Oh, yeah. You're right.
So what are we going to do next?
Cancel that out.
So this is y equals 1 over x minus 3 with holes at 3 and 4. Okay.
Weird.
Okay, that's as far as we're going to go today. We'll talk about the other asymptotes tomorrow. We need to, you need to do 1 through 18 on 495.